This is a topic which we are going to cover in this presentation, sir. We'll be explaining about what is Docker, why should we use Docker, the difference between the Docker and Kubernetes, the image versus the container, the Docker client, the daemon, the registers and object, the Docker architecture, and we'll be end up with the conclusion. Firstly, we'll talk about what is a Docker. So, basically, what the Docker is, it's like an open source platform for the developer, which allow developers to build the application, to run, to test, to update, and manage the container and the multiple more things, which is actually standardized executable components, which actually combines the applications, the codes, the source code of the application, the operating system dependencies, and the library which is required to run the application on a particular system. Right? It is very portable, artificial, and easily shared and the distributed system. It makes the developer very easy to deploy the application and build the applications. If I talk about why should we use the Docker, so there are the few functionalities or the few factors which affect why should we use Docker. So first one is the portability, consistency, isolation, efficiency, and the DevOps enablement. Portability means like the Docker ensures application which is running the consistently across the different environments. Let's suppose a team which is working on the Python some project and they require some dependency or the libraries need to be running the software on the particular system. So before the Docker, what developers and the DevOps team were doing is they used to go to the system and manually installing all the dependencies and the library which is required to run the software or application. But in the Docker, what we are going to do is we are going to make a file which is known as a Docker file, in which we'll describe all the dependency which is required to run the software application. And for the first time, we'll do this manually, and then later on, we'll just run the Docker file, which will allow you to update or make the system ready for the particular environment which you're going to use it or the deploy it. So the next thing, the Docker versus the Kubernetes will be continued by my friend.
Yeah, sir. Yeah, as my friend Deepak talked about Docker, now I'll be talking about difference between Docker and Kubernetes. So, Docker is a platform where the user will be developing, shipping, and running all their application in a single unit called containers. So, if we talk about Kubernetes, Kubernetes is also called as a K8. It is an open source container orchestration platform. Orchestration in the sense it's like automating the workload in a cloud infrastructure. So Docker is a container runtime, whereas Kubernetes is a service, container as a service, or even called as an infrastructure as a container. So Docker, the main work of Docker is to pack the application with all the dependencies, necessary packages, and code as well into a unit called container. Whereas the actual work of Kubernetes is to manage many containers in a single place. Uh, like especially it will be using Docker containers in Kubernetes called pods. So pods is a smallest execution part which will be installed on which will be installed as a layer on an application segment. So every pod will be having its own IP address, different IP address, so that it can communicate with each other like each other in the system. So if you talk about the installation part, setup is easier in Docker than Kubernetes. Like in order to access Docker, Docker engine is used to we have to install Docker engine, then we can access Docker. Whereas in Kubernetes, after one install, we should set up the nodes and pods network, etc. and other stuff.
Okay.
So if you talk about images, the difference between images and containers. So images, Docker image, it's a template for creating containers. Like to run a container, we need a image. Okay. So container is a running instance of image. So we can create multiple container using a single image. Okay. So what does the image contain? So the image contains all the dependencies, libraries, all the necessary things needed for an application. So container, container provides us a isolated environment where we can manage, run, deploy our application and make any other changes stuff. So images are immutable. So once it's created, we cannot change. Rather than that, we should again start creating it from the scratch. Okay. So container is a container is container is a lightweight and portable. So we can easily start, stop, manage the container using some basic native commands like docker run, docker docker restart, docker stop. So images can be shared and reused across different instruments. So like for example, we can say Docker Hub. We can share our images as a public or private in Docker Hub, or we can access other images like Nginx image. So uh, Docker Hub is an example for registry. So as I said before, we can easily manage the containers like using some native commands. So inherits the file system and configuration from the image. So the container retrieves the configuration data from the image and retrieves. Next.
So the now the clients and the daemon, right? So the client is nothing but it's like a interface. It's a CLI of the Docker, which is the command line interface that basically used to interact with the user or the developer, and then it makes a HTTP request if they need it. Like let's suppose we are just executing any command like docker push pull or run. So it fetch HTTP request to the daemon, and daemon what it does is it takes the HTTP request from the clients, and then it takes the thing which is requested by the client from the repository or the registries, and then it execute it. And the client used to interface with the Docker daemon, and one more important thing is like the Docker client can actually interact with the Docker daemons running on the locally machine or remotely on the other machine. Like the client can be running on the same machine, and the output can be on the remotely on the host or other session machine. And the daemon is like a background service which handle all the functionality which is going on the backgrounds. It is responsible for the like building and images, the running containers, the resource allocation, then the image management. So let's suppose if a client is trying to execute the command called build, like build or something. So
Mm-hmm.
it takes the request from the client, and it fetch it works accordingly from the registries. And the running containers, it used to run the container also in the background, which is not shown on the front sides. Right. So now the
So
registries and the object will be continued by the Lithium.
No,
so
just a couple of queries. Um, in a couple of your slides, I saw that you are saying it is portable. Just wanted to make sure that
Yeah.
you really understand what makes a Docker container portable. Uh, can you give an example when you say portable? How portable it is? How is it? You're saying that a Docker container uh, can be portable. Why? What is the
So the
reason?
port. Okay. Okay. So the portables, what before the Docker, what we were doing is like if a developer needs to develop anything on a system, so they used to do all the things manually, like the dependency or the required for the application which is needed to be run. And it was doing everything manually, so there were a chance that encounter some silly mistake which can be lead to the huge mistake later on for the applications. But now here, after the Docker, what we are trying to do is we are just making a Docker file. In that file all the libraries and the dependencies will be described, and once the file is running, then all the dependencies or the library which is required to the run the application will be set up on the system. So it's quite easy to just call a file rather than doing everything manually, sir. And that's how the Docker is very portable.
Okay, so it is partially correct, but let me tell you the exact with example how we are saying it is portable. Okay, so for example, you know the stages, right? How it evolved. It started with a physical machine, right?
Yes, sir.
Then came the fashion of virtual machines, like virtualization, hypervisor, virtual machines. Now they thought again the systems can be utilized more efficiently. Then came the concept of Dockers and containers, right? So that is how we have evolved. If I give you the example of portability, why we are saying portable is actual example is, say for example I have a Windows machine, okay?
Okay.
I install Docker, okay, in my Windows machine. I create I I create a image for my own requirement. Say I'm creating a base Ubuntu image and installing something like Nginx or whatever is my requirement, and I'm creating packaging it as a image and pushing it to a repository. You know the examples of what is a repository. It's like Docker Hub is a
Yeah.
repository. Now that container image, right? Okay, that
Yes.
I can give it to you. Say Deepak is
Yes.
running a Red Hat Linux machine. He might be having a Red Hat Linux machine. Here, the same thing he has to do. Step one is installing Docker, right?
Right.
And you can use the same image. That is why it is called portable. Okay, I
Yes.
created that image in my machine, which is on Windows. I, I installed Docker. I created an image. I pushed to the repository. Now, who is using it? Anybody can use it. Say Deepak is having a
Yeah.
Red Hat Linux machine. He can pull the image and he can run that container. Okay, image. Say
Right.
Gopi is running a Ubuntu machine. Okay, you can also do the same thing. Install Docker, you can run. So it is actually platform independent. That is why we
Yes.
call it portable. Okay, so
Right.
regardless of what is the underlying operating system, okay, I created it in a Windows machine, but you guys are running in a different operating system. In Linux, one guy is running in Ubuntu, which is a Debian Linux. One guy is running in a RPM based operating system, which is Red Hat Linux. Somebody else is running in some other flavor, some other operating system. So this is the
Mhm.
actual meaning of portable. So once you create an image, that image can be used regardless of what is the underlying operating system. Got it?
Right. Yeah. Got it.
Yes,
That
sir.
is why it is
Got
called
it, sir.
portable. You create once, you can run it anywhere, any place.
Right.
Any place in the sense, basically we are referring to any operating system.
Operating.
Yeah. It is, if I say if I created a Docker image in Windows machine, and if I say it can run only in another Windows machine, then it is not portable.
It's not.
Okay. So that is the
Yeah. Right.
concept of portable. So this is something which probably you can keep in mind. I'm sure you will not forget this example of being portable.
Yes.
The other
Yes.
thing is the evolution I told you, right, from physical machine to virtual machines, and from virtual
Yes.
machines to Docker containers. So,
Docker containers.
okay, are you able to visualize what made, what was the need for this evolution?
Yes.
Why people thought of bringing in all these new things?
Yes.
Again, I'll give you one more example. Okay, I have a powerful machine. Okay, I have a
Okay.
powerful machine. Say I'm with 32 GB RAM. Okay, and I'm running some applications. Say I've installed Microsoft Office or whatever, something I have done. But can you make sure that your machine, you take the example of your laptop itself, right? It is a physical machine.
Yes, sir.
You have installed few applications. So, but are you sure it is 100% utilized?
No, sir.
No, sir.
No, right? We cannot make use of 100%. Say you might be, your laptop might be used to say 60% when you use all your applications, because you can use only one application at a time, one or two applications, right? Meanwhile, if you say 60% utilization is there, for remaining 40%, can you give that laptop to somebody else for
No,
working
sir.
together?
No, sir.
You can't do that, right? Right? So,
Right,
Yes.
sir.
because it's a physical machine, only one person can sit and work at a time. So, but this 40% is underutilized. So, they came up with the concept of virtualization. And the same physical machine is virtualized and given to multiple people so that it is utilized in a better way. Now, coming into virtual machine itself, can we make sure that that virtual machine is fully utilized?
No, sir.
Yes.
Again, there will be a
Yes,
gap.
sir.
Within the virtual machine itself, there will be a gap, right?
Right. Right.
So they came up with this idea of containers,
Containers.
okay, wherein containers will have only those libraries and whatever is required for running an application, okay, lesser overhead and maximum utilization, okay. Now,
Yes.
after Docker and containers, they thought they should be able to deploy containers into multiple servers. How will we do that? For that, we need something called as Kubernetes or Swarm or Mesos, which is an orchestration engine. So you can have n number of physical machines. You can create a Kubernetes cluster or a Swarm cluster or what Mesos cluster, whatever, and you can uh, create Docker containers and manage it and scale it up and scale it down across physical servers. So if you are able to visualize this right concept,
Yes.
it is easy to
Yes, yes, sir.
understand. Very easy to understand.
Yes.
Okay. Uh, yeah, that's what I wanted to highlight. Please continue.
Okay.
Sir.
Thank you, sir.
So, uh, so, sir, Gopi, can you please mute your mic? Yes, sir. Thank you. So, difference between registries and objects. So, as I said before, a registry is a place where all the official images, or even we can store our images. There's a website called Docker Hub, owned by Docker itself. So, this is the place where all the images are stored. Like if I want to access the Nginx image, I can go there and access, or else I can directly go to my terminal and type the Docker run and the Nginx with the if I want a specific version, then I go with the version like
That's
Docker run Nginx
that's
is to
called tags.
12.1.
That's called
Yes,
tags.
yes. So registry can be both public or private, or we can even create our own image and add it in the Docker Hub on premise. So
That
if
is
you
what
talk about object,
that is what we are going to do.
sir,
That is what we are going to do.
yeah, sir. Yeah, yes. So if you talk about objects are like a set of files, like configs. It's a blueprint or thumbnail to create a container. Like it's a set of instructions while creating a container. So it is created along with the container. When the image is executed, it's created along with the container and stored in the registries. So, yes. Open next.
So now coming to the Docker architecture. So basically, the Docker architecture follows the client server architecture. So here we can see the mainly three components: the clients, the Docker host, and the registries. So the client, so in the client, as I've explained before, client is nothing but it's like a CLI of the Docker from where we used to run the commands, or we can say from where we used to make a HTTP request to the Docker daemon, and our the request get fulfilled. So just now in the previous slide, my friend explained the registry, what the registry concept, where all the files and the official images are getting stored, right? So here basically three commands are depicted in this clients: the build, pull, and the run. Right? When we try to execute any command, let's suppose I'm trying to execute the command called docker build. So it takes the request, it gives the request to the Docker daemon, and Docker daemon what it try to do is it takes the images from here and from the container and it try to run this. So that's all the Docker architecture is. A client used to make a HTTP request to the daemon, and daemon which handles all the functionality, the background services which is needed to run the commands. Right? It takes the data, or we can say the absolute file from the registries, and that's how the architectures of the Docker works on.
Okay.
So in the conclusion part, I would like to say that with the development of Docker, it has been a major advancement in for developing and deploying, which makes the developers development and deploying much easier than before.
Yeah.
So it's also user friendly and strong ecosystem and powerful tool for modern application development. Like for it may be even more useful in deployment, as my friend Deepak said. Like there will be no need of installing much tools. It may be a time consuming. So instead of that, can directly go and work in the Docker.
Right. So that's the
With one click,
evaluation
all
of.
the tools have been readily installed.
Yeah. So
So,
just to add a
sir,
note is the previous way of application development, or you call it a software development where waterfall method and all you would have learned, right? So that is like obsolete
Yes.
now. That is no more in use, and most of the organizations have moved forward with newer strategies of software development and all those things. Say you would have heard of agile methodology and all, which makes it very faster.
yes,
So only if strategy change, nothing is going to happen. So we should have all good tools and technology in place, so that that also speeds up, right? Only if you change the strategy, nothing
yes,
is going to happen. So application development strategy, software development strategy has changed, and on the other side, parallelly, this technology also has evolved from a monolithic architecture. Monolithic architecture was the earlier way of doing things, right? Installing something on a
yes,
physical server and running it. It is not utilized fully. Resource wastage. I explained the examples, right? Physical server to VM to whatever, and DevOps tools and what is it? Automations and all those
orchestration
things are coming in.
tools.
So what happens is nowadays the development cycle, right, is very very fast, and it is almost continuous. That's why we call it as CI/CD, right? Continuous integration, continuous delivery.
Yes,
development.
development.
Yeah. So together it enables. So we have moved away from this monolithic architecture to microservices. So for microservices, yes, we need to have a Dockerized environment. The application should be Dockerized, and we should be able to scale up and scale down on demand. That elasticity, right? So,
Yes, sir.
that is what is the current way of doing things. Okay, thanks. Thanks for.
Thank you, sir.
Thank you. Next.
Thank you, sir.
Now the Kubernetes will be presented by the Gopi and the Krishna also.
Sure.
So
Yes,
I'll
sir.
just turn off my sharing screen, sir.
Yeah.
Yeah, Gopi, you can continue.
Is my screen visible?
Uh,
Yeah, visible.
Yeah,
yeah, coming up. Yeah.
Yeah. When it comes to Kubernetes, as my friends Deepak and Likit discussed about the Docker,
Can you click on that hide?
So
Can you click on that hide? Next
Yes.
to stop sharing. Yeah, yeah.
Okay. When it comes to Kubernetes, Kubernetes is used to work with the containers which is uh, hosted in Dockers. So why Kubernetes is necessary in the sense, when it comes to Kubernetes, Kubernetes is an orchestration platform which is a centralized hub to manage the n number of containers which is created in Docker. So um, the management of containers is not that so easy when it comes to large number of containers to work with it. So Google has created this Kubernetes to uh, ensure the seamless and continuous availability of the containers which is created in Docker. So Kubernetes can deploy the containers created in Docker uh, with different number of configurations like scaling and different processes which is controlled by master node, and the master node provides the management to the worker nodes in a cluster. So the next why Kubernetes is required will be explained by Krishnaraj.
Hello, sir.
Yeah,
So, am I audible to now?
yeah, yeah.
So, why Kubernetes? Say, since if the main case of Kubernetes simplify the deployment of the containers. So, we can deploy our multiple containers in Kubernetes. So, we can manage and can scale up and scale down. We can create multiple replicas of our Docker containers for our backups, and we can able to scale up if you want to scale up your containers and make that available for everyone easily, and it provides multiple tools for the container to monitoring logging and so on. So there's a lot of tools for available in Kubernetes to for the user to use their containers in the Kubernetes platform, and main use this it can able to maintain multiple CSPs, so like the AWS, GCP, and Azure, and multiple cloud platforms, and it easy to install in every machine. So, can you move slide, please?
So the next part of the Kubernetes is key features, which is nothing but the components of Kubernetes. When it comes to components, um, these are the main applications where container orchestration. It is um, it manages the deployment, scaling, and networking. In the sense, Kubernetes cluster contains two parts, which is a master node and a worker node. So master node contains mainly three processes, which is a API servers and manager and other controller and etcd, which contains the configuration. So the next one is service discovery and load balancing. When it comes to the management of containers, so there will be in every nodes there will be having different pods. Pods are nothing but a smallest unit of containers which contains applications like and other kind of
It is
applications.
nothing but
So
Docker
to,
containers only. When it comes to
yes sir.
Kubernetes, few terminologies they use it from their side.
So that is managed in different nodes for availability, high availability, and replicas and auto scaling and load balancing. So uh, mainly Kubernetes is focused on the continuous availability of the uh, applications, where it comes to the uh, nodes. uh, it has mainly different processes to maintain the uh, availability time. So here you can see self-healing and automated rollouts and rollbacks, secret and configuration management. These all are done by the processes. There are some processes named as service, which provides the IP address for the pods, and secret, which contains the uh, critical information like database passwords and usernames, and configuration management. It is a process which mainly focus on the uh, configurations of nodes containers. So this is the Kubernetes architecture. So you can see here, um, here here we have a,
I think your screen is freeze frozen.
so
Yeah, now we can see.
so
No, no, your screen was frozen. Now we can see the architecture.
okay, yes. So when it comes to Kubernetes architecture, so we can communicate to the Kubernetes using these two clients, which is a user interface, which is provided by Kubernetes, and CLI is nothing but a command line interface, which is named as kubectl in Kubernetes, and this is the uh, master node, which manages the worker nodes. uh, Here in Kubernetes cluster, we can have a minimum two master nodes and a number of worker nodes, where two master nodes used because when a single master node goes down, we can use another master node to maintain the worker nodes. So you can see an API server. Uh, Users can communicate to the API server initially, and through API server, they can communicate to the worker nodes. So we can schedule the deployment, and controller manager and the etcd. Etcd is the main thing which contains the present status of the configuration in all the worker nodes. So we can replicate, and we can recover the configuration in etcd. So when it comes to worker nodes, so worker nodes can contain any number of pods. Pods and pods can contain any number of containers. So by this architect, we can manage the Kubernetes using single master node or multiple master nodes, which reduce the work of an operational management team. Uh, exactly. So here are the processes running in a worker nodes, which is kubelet and kubexy, and these are the architecture, which is master node controls the cluster and manages its state, and worker nodes and components. So these are the major components which we will configure in Kubernetes to manage the Kubernetes cluster overall. So how it works will be continued by Krishnara.
So, see, first we have how we gonna create a deployment in the Kubernetes. So first we have to create a one file. It's we can create a YAML or a JSON. So we prefer YAML. Okay, there we have to mention our containers, pods, and everything, and you have to apply in our machine. Once you apply it, it will run and it's ready for deployment.
You'll be using
So why
kubectl
we
for it?
So
Will you be using
Sir?
kubectl for applying the YAML file?
yes,
Yes,
we
yes,
can
yes,
use
yes,
it.
yes.
Okay.
We so
So
two methods. So we can use UI or CMD. So we prefer CMD because we can able to understand the working of working in the
Okay.
CMD. So we prefer doing so.
Okay.
So why episode? We use episode for the communications, for sending the request, receiving the response, and why scheduler. The schedule is a control plane process which assigns pods to nodes. We used to orchestrate the pods. contain contain the software.
I think your
So
voice
they deploy to someone
voice is
else's
not.
availability.
Looks
I
like your
guess
voice is
Krishnaraj's
breaking.
voice is breaking.
So uh, am I audible now?
Yes,
Yeah, yeah, you are audible.
some disturbance.
So it's okay, so sorry. And and the control manager. And the control manager is responsible for monitoring the current state of your cluster through the API server and makes appropriate changes and keep the application running in the pods in healthy state. So it ensures the pods are running safely and healthy and reports to the users. And last Kubernetes. This Kubernetes service is running on the worker nodes. It's indexed with both container runtimes. That's Docker and the node, and it's responsible for starting a pod with a container installed. Can you say the speed, please, slide, please? So, how we gonna start with Kubernetes? Step by step installing. So first we can use any platform like AWS or Azure or any VM you prefer, and install and configure Kubernetes using the our website. They provide the whole configuration files there, and you have to mention your containers info in your YAML file or JSON files, and you can use your kubectl which is runs on the worker nodes to deploy your container and manage it, and you can be able to provide a monitoring and logging for your containers.
Okay.
So
You can carry on.
when it comes to the conclusion, um, Kubernetes is majorly used for deployment of the containers itself. So when it comes to the deployment, uh, it should deploy in different environments like cloud or physical or virtual machines or hybrid machines also. So we are using Kubernetes for easy deployment of many number of containers to manage it in a centralized hub. So for the demo purpose, we can use different tools like Minikube and other tools also. So we just tried using Minikube, which is a simplified tool to install in our system,
Okay.
and we can work it on, and test the Kubernetes deployment here.
Okay. 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 So even I I have not tried any other orchestration tool other than Kubernetes. Maybe when you get some time, just look at the other tools like Mesos, Docker Swarm, right?
Yes, sir.
Nothing wrong,
Yes,
nothing
sir.
wrong in knowing more things, right? So it's always better. So you can do a comparison also, like using Kubernetes, how you can manage the Docker containers, if it is Mesos or Docker Swarm, how different it is, and all those things. So that will be a good exercise when you do a comparison. Uh, yeah, that's one suggestion to make.
Sir,
Yeah,
sir, in Kubernetes, I would like to add another point.
yeah,
So there's something called a config map, sir.
okay.
Config map.
Mm-hmm.
So, for example, I'm running a web application.
Mm-hmm.
So I want to change the URL of a particular page in my application.
Mm-hmm.
So instead of going to the program, changing the URL code, and then uploading it to the Git, and
Okay.
then publishing, instead there's something called config map. I can directly go to the config map.
Mm-hmm.
There I can change URL with just one click.
Okay. Okay. So that's part of configuration management actually. That is what is configuration
Yes.
management. So you need, when multiple places you have deployed, you might otherwise change the code inside, right? So from outside itself, you are able to change things. So that is the configuration management actually.
Yes.
So that is part of the configuration management. And there is something else also. Probably it would be good to look at, say, Docker containers and uh, 1 minute. I will just a
Friends.
minute. Hello, hello, hello. So now we are talking about multiple layers, right? So when we talk about virtual machine, one more layer is created, and when we are talking about Docker and containers, another layer is created. So these things should be exposed also, right, outside for accessing. So there are multiple ways to access it. For example, there is something called cluster IP, node port, and ingress,
Ingress.
right? So that mechanism also is something which we should understand clearly, so that we understand how is it we are exposing these Docker containers, um, and making it highly available with load balancer and all those different options, right? So that also
Yes.
probably, if you add it, uh, two things I want you to look at. One is comparison between Kubernetes and Mesos and Docker Swarm, whatever. Okay, that will be a very good exercise. You'll have clarity. I have not tested it myself, for sure. Other than Kubernetes, I have not done anything. The second one is this exposing, right? How you expose your applications to the outer world using different options like cluster IP, node IP, ingress port, and all those things. Just start looking on that part also, so that you'll have a better idea.
Yes, sir. We are working on that, and it's also a part of our project also.
Oh, great, great. Then probably
Yes.
Yes, yes, sir.
definitely you'll be knowing it. So make sure that you, all four of you, look at these things as a team, so
Yes,
that
sir.
you need not
Yes, sir.
repeat, right? If you start
Yes, sir.
looking at things together, easy, it'll be easier.
Yes.
Yeah, it was a good session. We
Thank you, sir.
can definitely see the hard effort you have put in to
Yes.
do this presentation. Uh,
And sir, you
yeah.
told that after the installation of Dustech, you will just explain how to work on the project.
Yeah.
Uh, hold on, hold on. I'll let you know. Don't deviate. You finish your exam and everything.
Yes.
That's why I'm not pushing anything.
Yes, yes.
Yes, sir.
I'm not pushing. I'm saying these things just whenever you're getting time, you do. Finish off your exam when
Okay.
things are free,
Yeah.
right? Uh,
Yes, sir.
Yes.
I should not be assigning anything to you,
Yes.
because since you are still not officially in, I don't want to assign anything for now. Okay. So slowly things will turn. The more and see, the planning is in such a way that you start. I'm making you ready slowly.
Yes.
Things you can
Yes, yes,
expect
yes.
and all those things, right? What is
Right.
coming? That's what. So once you start, probably then it'll be like full time. You'll be working on things. So that will be a different thing. So till then, you take it easy. Uh, Casually start looking at these things, so that you understand what is coming on the way. Okay.
Sure,
Right.
sir.
Anything else? Anas, any comment from your side? How was the session? You're on mute.
Yeah, yeah.
Hi. Hello, sir.
It was a wonderful session, and I could able to recollect many things regarding the Kubernetes theory parts. I have wishes that as a demo,
Thank you so much
uh,
for a
for
wonderful
a
session.
wonderful
Thank you, sir.
Thank you, sir.
Thanks.
Yeah, thanks, Anas. Okay, thank you guys. Thanks for your time and effort. Appreciate it.
Thank you, sir.
We'll be.
Thank you, sir.
Thank you.
Thank
Thanks
you.
for options.
Thank you. Bye.
Thank you, sir.
Nice.